Applying systems. Our objective for today: I can solve real-world problems using systems of linear equations. Read together. 1, 2, 3. I can solve real-world problems using of linear equations. And we already know how to solve systems 3 different ways. Is that correct? Using graphing, substitution, and elimination. But today we're going to start applying them to real-world problems. Okay? So with that said, we don't need a Freyer model because we already know what systems of linear equations are. However, we do need a process. And from this point forward, whenever we get into some word problems, I want you to use this process here. So title it Problem Solving Strategy. Problem Solving Strategy. And this process usually works for all word problems. So the first one. Number 1, read the problem at least twice and underline key information. Does that sound familiar? Yeah, that makes sense, doesn't it? Step 2, use a table to organize information and use variables to label. Choose variables to label. Step 3, reread the problem and write expressions or equations to represent relations. Step 4, solve the equations and find the unknown. Step 5, check. Copy that, please. So just to recap, step 1, read the problem at least twice and underline key information. Step 2, use a table to organize information and choose variables to label. Step 3, reread the problem and write expressions or equations to represent the relations. Step 4, solve the equation and find the unknown. Step 5, check. So, here goes the first example. Example number 1. Copy this one. It says, Alyssa has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. How many sheets of each can Alyssa buy? Copy that, please. All right, so here it goes again. I already read it. I'm going to read it one more time. It says, Alyssa has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. Does everybody know what a scrapbook is? Yeah, right? Where you put a lot of mementos and you want to create like themes and stuff. Yes? Yeah. Or have you seen those movies where there's a stalker and they grab stuff from people and they put together in one? That's a scrapbook? No? Well, yeah, something like that. All right. So, and felt is a material that seems, it's kind of like construction paper, but it's cushioning, kind of like foam. That's felt. And cardstock is the one that they use for your student IDs. It's thicker than construction paper, so it doesn't bend easy. So, now that we have the idea, let's go back and circle stuff and underline information. First thing that calls my attention is how much Alyssa's going to spend. So I'm going to box $7.75. That's the total that she's going to spend. What other information is important here? Since I started with money, I'm going to box 50 cents, and I'm going to box 75 cents. All those with red. So if you have your colored pens, use those. Good. Next, the next item that calls my attention is how many items Alyssa's going to buy. How many items? 12 sheets. 12 sheets. What kind of sheets? Sheets of felt and cardstock. So that is important information. Okay? Now that we have that, now let's draw our table. Here it goes. The table never changes from this point forward when we get to word problems like these. 3 lines down, 1, 2, 3, 2 across. So step 1 was read the problem at least twice and circle or underline key information. Did we do that? Step 2, build a table, here it is, and label it using variables. So, with that said, what is the first information that we started with? The amount that Alyssa's going to spend. That's going on the first row. So all this row will be the what? The cost. This first row, we're going to label it cost. So what is the total cost of the materials? $7.75, and that usually goes at the end. Is that correct? So we're going to label this column total. What other costs do we have? That one of the sheets cost 50 cents, so we're going to write 0.50 on this column, and this one cost 0.75. Are we there? Now check this out. If I was to cover this problem like this, and we just have this table, and somebody walks in that hasn't seen this type of setup, do they know what we're talking about using just the information there? Well, okay, they know that we're going to spend, right? But do they know what we're talking about? No, because we don't have any labels. Does that make sense? So therefore, what does the 50 represent? Felt. So therefore, this column we're going to label it. Oh, sorry. We're going to label it felt. This column we're going to label it what? Cardstock. All right. But since they're asking us to use variables, do we know we know it's 50 cents per sheet. Do we know how many sheets she buys? No. A felt? We don't know. So we can label it X, but since we have a variable already, what variable could we use? F, 0.50 F. So for the cardstock, it's 0.75 what? See? Do you see what I did right there? All right, so we're done with the cost. Let me remove this. All right, so we're done with cost, so we're done with all the red stuff. So the next row is going to be the items. Items. How many total items is Alyssa buying? 12, that goes down here on the total. Do we know how much felt? What can we label that? F. And do we know how much cardstock? C. Now, I heard earlier somebody say right now, somebody said label this one X, we could label this one Y. But what do we know about systems? That they need to have the same variable. So if we started with F and C, that means that these need to be F and C. Okay, so with that said, at this point, look up please. These problems, when we get to the party, are worth 5 points, or if I multiply times 2, that would be 10 points, or if I multiply times 3, that would be 15 points. The first point will be because you would fill out the table correctly. The next point is writing your equations using this information. So look up. I'm going to write my first equation. Pens down, look up. My first equation is 0.50F plus 0.75C equals 7.75. Does everybody see where I got that from? So what would be my second equation, everyone? Equals 12. Copy that, please, and now we have a system. So let me scoot this up a little bit. And there it is. Where? It's at. It's plus. So, I'm going to zoom in. Here it goes. So do you see where we got the equations from? All right, so now we end up here. What does that look like? A system. Can we solve that system? Yes. Which variable would you like to eliminate? David. David said F. So if we were to eliminate F, what needs to happen here? Multiply times -1/2 or -0.5. But what if Noemi wanted to eliminate C? What would we need to multiply everything? Negative 0.75. So let's eliminate F. Multiply everything times negative 0.50. So let's distribute. This becomes negative 0.50 F. This one is negative 0.50 C. And this one is negative it's negative 6. All right. At this point, put the wiggles on the middle one. We're no longer going to use this one. We're going to use the top one and the last one. So now let's eliminate. What is 50 minus 50? Cancel. Okay. What is 75 minus 50? 0.25 C equals 775 minus 6, that's 1.75. Okay, what is our last step? To solve for C, divide by 0.25, divide by 0.25. C equals, you could do the long division, or you can think of it like this. It's 175 divided by a quarter. How many times do quarters fit into 175? 7. So therefore, she's going to purchase how many? 7 card stock sheets. Yeah, we're using the elimination process. Very good. So, let me zoom out. So we're done with solving for C. But now we need to solve for which one? F. So I'm going to use the items equation, which is F plus C equals 12. And you're saying, Mr. Q, but I can just do this in my brain and find out what the other one is. Yes, but I don't want it in your brain. I want you to show me the work. So therefore, C is 7. F plus 7 equals 12. Minus 7 minus 7. F equals 5. Therefore, 5 what? Felt sheets. So let's answer the question with a statement. It says, how many sheets of each can Alyssa buy? Alyssa buys, which was the first variable of the first column? F, so I'm going to start with felt. Buys 5 sheets of felt and 7 sheets of cardstock for $7.75. 10Q. So let me break down the points, how this is going to be graded. 1 point, you got to make sure you fill in your table correctly. Second point is setting up your system. Third point is solving for the first variable. Fourth point is solving for the second variable. And the fifth point, you have to have a statement. Yes?
So then why would I don't see
Depending on the scale. If I was to scale it by 2 points each other problem, then these will be times 2, that's 10 points. Yeah. So let me go backtrack the steps. Step 1, did we read it at least twice? And did we box for the underlying information? Yes. Step 2, did we write a table with variables? Yes. Step 3, did we write equations? Yes. Step 4, did we solve for the variable? Yes. And step 5, did we check? In a sense we did, because we substitute this in here and it works. But if we were really wanting to check, what is F? 5. What is C? 7. 7 plus 5 is 12. And if we were to substitute those in here, will that give me a total of 775? Yes. Okay. Copy this next one down, please. Example 2. It says, Raj spent $14.85 to buy 13 flowers. Oh. He bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Raj buy? Copy that, please. Once again, I'm going to read it again so I can start underlining stuff. Raj spent $14.85 to buy 13 flowers. He bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Raj buy? So the first thing that called my attention is how much he spent. What was the total? $14.85. What other amounts of monies do we have? $1.25 and 90. Okay, so I'm done with amounts of monies. Let's go to items. How many total items? 13 flowers. Okay, what kind of flowers? Lilies and tulips. Alright, so with that said, let's write a table. 1, 2, 3, 2 across. Now let me show you something. Let's see, on the previous one, what went on the first row? The cost. Do we have a same kind of problem on here? Yes. So what goes here? Cost. What is the total cost? $14.85. We'll label that total. What other amounts do we have? 1.25. And what else? 0.90. And what does the 125 correspond to? Let's see. You bought lilies, which cost 125, so I'm going to label this one lilies. That means the other one is tulips. What variable do I use for lilies? L. What variable do I use for tulips? T. But look how I'm going to write my T so I don't get mixed up with pluses. I'm going to write it like that. So I'm done with the cost. Now I'm going with the items. So how many total items? 13. Do we know how many lilies? No. Do we know how many tulips? No. Okay, let's write our system. 1.25 L plus 0.90 T equals 14.85. And then the second one is L plus T equals 13. So, which variable would you like to eliminate, Marissa?
Oh,
Are you asking me or are you telling me?
telling you.
So you want to eliminate L?
Huh?
L? Okay. So we multiply times negative 1.25. This becomes negative 1.25 L minus 1.25 T equals negative, let's see, 13 times 125. This becomes 15. I got 1, 6, 7, 3, 1, 2, 5, 5, 12, 6, 1, 2 decimal places, 1625. All right. Put the wiggles in the middle. We don't use that one. We're going to use the top and the bottom. So 125 minus 125, they cancel. 0.90 T minus 125 T, what does that give us? What is it? Negative 0.35 T equals 1485 minus 1625. What is that? Huh? 1485 minus 1625. What is it? 260? Alright. Negative 260. Alright, so with that said, what is our last step?
Divide by .9.
Negative 0.35. Negative 0.35. We're left with T equals let's see, 2, yeah, not bad. This becomes negative 1.40. And now we divide. So 140 divided by 35 doesn't fit into 14, into that it fits in there 4 times. 140. So how many tulips? 4 tulips. We use the item equation, which is L plus T equals 13, and I substitute, how many tulips were there? 4. Bring everything else down. L plus 4 equals 13, minus 4 minus 4. L equals 9. Lilies. So, what is our statement? What would be our statement there, David? Raj buys 9 lilies and 4 tulips which oh, not which, but for 1485 10Q. Yes. Here? This is the cost. What was the total cost in money? How many items did he buy, according to the information here? 13. Okay? Copy this next one down, please. Example number 3. It says, with a tailwind, an airplane makes a 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the plane's speed? What is the wind speed? Copy that, please. All right, who notices on this one that it doesn't talk about money? It doesn't talk about items. This one is talking about time, distance, and rates. That's why this kind of problem is known as a rate problem. But the setup goes the same. So I'm going to start reading it again, and I'm going to go labeling stuff as I read. So it says, with a tailwind, okay, that sounds important. I'm going to label tailwind, okay. An airplane makes a 900-mile trip, so that's important, 900 mile. And how long? In 2.25 hours. Okay, so that's the trip. I'm going to change colors now to blue, and it says on the return trip, okay, return trip, the plane flies against the wind. I'm going to box against the wind. And it makes a trip in 3 hours. 3 hours. But notice that they don't mention the distance again, because they assume we know, right? So what is the distance? So I'm going to box it also in blue so that I know that I need to use 900 twice. So with that said, now that I labeled it I read it twice at least. I'm going to build my table. Same table that we used before. 3 lines down, 2 across. The only difference for this one is not the same as the other in regards to the columns, the name of each column. In this case, I'm going to use a formula. And I'm pretty sure you guys that you're in your science class, right? You already know the formula I'm talking about, right? Rate times time equals distance. Rate times time equals distance. And I'm pretty sure your teacher maybe introduced it as the DIRT formula. Who's heard of the DIRT formula? Distance equals rate times time, right? All right. So with that said, now that we have this, who noticed that on the previous ones, the very first information, I placed it in the first row. Does that make sense? So what is the first thing I'm going to write? Tailwind. Tailwind. What is the distance, total distance of the tailwind trip? 900. What is the time it took them? 2.25. Okay. And the rate, this is what's a little bit different. Rate is going to involve 2 things, the plane and also the difference that the wind makes, because that affects your rate. So who's noticed when they have you guys running the mile and it's windy, what happens when you're running against the wind? It's harder, or it slows you down, is that correct? But what happens when the wind is at your back or at your tailwind? It increases your rate, is that correct? So therefore, this is how I'm going to write rate. The planes increased by the wind. Does that make sense? Bam! So we're done with this row. Let's go with the next row. This was the tailwind. This one is against wind. Once again, wasn't it the same distance? Yes, 900. What was the time? 3. And Noemi said it was P minus W because it decreases because it's going against the wind. Does that make sense? Kind of when you're running against the wind, you're trying to run faster and it slows you down. You're like, oh, right? You're trying to beat your time. So check this out. So let's write our equations. Our first equation is P plus W, which is rate. What does this stand for? Times. How can I write times? In parentheses, 2.25 equals 900. I'm going to skip a line, and my second equation would be what? P minus W times 3 equals 900. That looks familiar, and we can start solving, but we have parentheses, don't we? So check this out. So I'm going to solve this bottom one so I can get rid of the parentheses. If the 3 is multiplying, I'm going to divide by 3, and we're left with P minus W equals, what is 900 divided by 3? 300. Okay, got that? This one, the 225 is multiplying. I'm going to divide by 0.225, divide by 2.25. I'm left with P plus W equals 400. And you could do your division, long division over here. So, does that look familiar? Yeah, right? Now check this out. So, let's eliminate a variable. Which one's going to eliminate? The W's. P plus P, that's 2P. 4 plus 3, that's 700. Divide by 2, divide by 2. So the plane speed is how much? 350 miles per hour. From there, I use one of these 2 equations. I'm going to use the top one. P plus W equals 400. I'm going to substitute for P the 350 plus W equals 400 minus 350 minus 350. W equals 50 miles per hour, and we just write our statement. Yes? What is P plus P? Yeah, we're combining. So our home plate for tonight is a play sheet that's over here by the computer. Grab one. There's tutoring today. If I don't see you, I'll see you guys tomorrow.